We live inside a galaxy so massive it bends the path of starlight, a rotating island of 100 billion suns wrapped in a halo of invisible matter. And somewhere inside this vast structure, drifting on a spiral arm, we ask a strangely simple question. Can we ever escape it? To answer that, we first need to understand what escape actually means. It's not about distance, it's about energy. Every galaxy is a gravitational well, a curved region of space-time shaped by trillions of solar masses. To leave it, you need enough speed to climb out of that curve. Right now, the Sun is already moving fast. We orbit the center of the Milky Way at roughly 220 kilometers per second. That's 790,000 kilometers per hour. And it still isn't enough. To break free from our position in the galaxy, we would need at least 550 kilometers per second, more than double our current velocity. No star in the Milky Way reaches that speed naturally. Not even hypervelocity stars ejected by black hole interactions always make it out. So what exactly is holding us in? It's the combined mass of everything around us: stars, dark matter, the central black hole, and the entire structure of the galactic disk. Think of the Milky Way not as a collection of stars, but as a gravity ocean. We're inside a deep basin, sliding along its currents. Escaping that basin requires an energy input greater than anything humanity has ever produced. Even our fastest spacecraft barely register on this scale. Voyager 1 is moving at 17 kilometers per second, only 3% of the speed required to leave the galaxy. If Voyager was aimed straight upward out of the Milky Way, it would slow down almost immediately and fall back into the gravitational field we barely notice. So does that make escape impossible? Not exactly. It's possible, but only if we think far beyond the technology we have now. Before that, we need to consider something even more important. Does escaping the galaxy actually matter? For most of cosmic history, the answer would have been no. Chemical rockets can't get us there. Nuclear fusion helps, but still falls short. There are theoretical ideas, though. Some involve using extreme gravitational environments, like slingshots around black holes. Others propose harvesting the motion of binary black holes, using their immense orbital energy as a halo drive. These concepts don't require fictional engines. They rely on exploitation space-time itself. But even then, the energy demands push the limits of what a civilization could realistically achieve. And yet, nature has already accomplished the impossible. A few stars, true hypervelocity stars, have been accelerated by interactions with the supermassive black hole at the galactic center. A handful are moving at over 1,000 kilometers per second. These stars can escape. A natural demonstration that the Milky Way's grip isn't absolute. So the answer is clear. Escaping the Milky Way is not forbidden by physics. It's just extraordinarily difficult. If humanity, or its descendants, are still around, we might hitch a ride on that transformation, carried out of the galaxy by cosmic dynamics rather than engines. In the end, escaping the Milky Way is less about technology and more about understanding our place in a changing universe. Galaxies are not cages. They're gravitational histories, collections of matter shaped over billions of years. We orbit inside them the way electrons orbit atoms, not trapped by walls, but bound by the laws of physics. Can we escape? Yes, if we master energy on a stellar scale, or if we ride the tides of galactic evolution itself. But the deeper question is why we would leave. Not out of desperation, but ambition. Because the universe is growing emptier. Because the window to explore it is closing. Because the galaxies we see today will not always be within reach. One day, the Milky Way will merge, evolve, fade, and transform. If we're still here, still curious, still reaching outward, then escape is not just possible, it's inevitable. The real question isn't whether we can leave our galaxy. It's whether we'll become the kind of civilization that tries.